So after having reviewed static gas separator, I would like now to discuss dynamic gas separators. Dynamic gas separators, they were introduced by Baker-Hughes in 1978. And this type of gas separator are typically used when the gas volume fraction at the intake is above 20%. As opposed to static gas separator, dynamic gas separator delivers effective work to the fluids to segregate gas from the liquids. So as they deliver effective work or energy to the fluids, this is why we call them dynamic gas separators. There are two main types commonly used: rotary gas separator and vortex gas separator. I will go through each type a bit later in this course, but overall they have a similar working principle and they are each made of 3 sections. So on this schematic over there from Baker-Hughes, we can actually see such a dynamic gas separator. So in this case, it is a vortex gas separator, and we can see the 3 main sections represented in it. So we have a first section, which is what we call the pressure chamber. And so the target of this section will be to increase the fluid pressure by using an inducer. So the inducer is this piece over there, which is attached to the shaft that we have in the middle. So it basically rotates with the shafts and it will basically push up the fluid mixture, so liquids and free gas, and push it up across the next chamber, which is the separation chamber. So this pressure added to the fluids inside of the pressure chamber is required to be able to expel the fluids across and outside of the separation chamber. So in the separation chamber, we also call it residence chamber. A rotating movement is going to be transmitted to the fluids. And as you transmit this rotating movement to your fluids, the liquid which has a higher density will move towards the outer parts of the separation chamber, while the gas which has a lower density is going to gather around the shaft. So that's what we can see there, where we can see that the bubbles are mostly gathered along the shaft, while the liquid is going to stay along the main casing of your gas separator. And so then, after having separated this way your liquid from your gas, due to the push provided by the pressure chamber, all this fluid is moving up to the next section, which is called the bypass chamber, so located over there. And so the target of this bypass chamber will be to expel the gas outside of the gas separator. So as we can see over there, your gas is being expelled outside of your gas separator while redirecting the liquid and sending it through the pump. So how does that work? Well, basically you're gonna have some vent ports in the middle like this. So you have this kind of cup this way, and so the gas is gonna enter by the middle as it was already gathered around your shaft. So it will enter this cup by the middle, and there you're gonna have some vent ports which are going to send it outside of your gas separator, while on the other hand the liquid is going to go around this cup and there will be redirected towards the center of your gas separator and then be sent to the pump. So after having introduced dynamic gas separators, on this slide I wanted to show the main components that you have in such a gas separator. And so you have several good pictures and illustrations on this slide. So the first one is this schematic that we have on the left, which comes from Valiant Artificial Lift. And so we've got a cut view of this type of gas separator. So what are the main components? So at the bottom of it, you will have large entry ports over there, which is basically the intake of your gas separator. In the middle of your gas separator, you are going to have a shaft. This shaft is going to be stabilized thanks to bearings. So the bearings in a gas separator are typically made of hard material like tungsten carbide. Why is that? Well, basically the standard is to use abrasion resistant material to stabilize the shaft in your gas separator, because inside of your gas separator, you have a high gas concentration. And as previously mentioned earlier in this training, gas is a very bad lubricant. So as it is a bad lubricant, this is why it is recommended to use this kind of hard material. And obviously, as this is abrasion resistant material, it is even more recommended if you want to use your gas separator in a sandy well. In such a gas separator, you typically have 3 bearings. One which is located at the bottom of your gas separator, which is not represented there. One which is located towards the top of your gas separator. So in this case, it's located just there, but it can also be located upper in your gas separator, and you typically have one just below the separation chamber. Next component that you will find inside of your gas separator is the inducer that we can see over there. And so I have two pictures of such inducer over there on the slides. So as you can see, you can have different designs. So we've got this one and that one. That's two separate design. So basically this will be based on the choice of the manufacturer that designed and sell this gas separator. So within your gas separator, you will have then your separation chamber. So in this case, this is a vortex gas separator, and there you have a vortex generator. And at the top of your gas separator, you're gonna have vent ports. So these are the ports that will be used to expel the gas outside of your gas separator. And so we can see the picture of such ports on these two gas separator pictures. Over there, we've got another gas separator that we can see, and we can see in this case just there the vent ports of this gas separator, while just there are the intake ports of your gas separator. And on this slide then we've got a last schematic over there. So in this case it is another gas separator schematic. This one is from Baker Hughes. And so we can see the same elements that we could see on that one. One thing interesting to mention is that the inducer over there, it is also called an HAVA, which stands for high angle vane auger. So it's just another way to call the inducer. And on this schematic, we can also see the vortex generator, which on this schematic, we can see the name of it. So it's called a guide vane. And so that's it for this video to introduce dynamic gas separators. Now let's move to the next topic and let's have a look at the two different kinds of gas separators that you can have.